everyone. Welcome to Encrypt. My name is Siddharth, and today we'll be learning about recursions. So, what is recursion? Recursions is a process in which a function or a method calls itself repeatedly. It can be used to solve a complex problem by breaking it down into more simpler and smaller blocks. So, to give you an example, imagine that you have a box full of $100 bills and you need to count how much money you have. Since it might be a lot, you can probably ask for help from a friend and you can divide the stack into two. When both of you finish counting, you can just add up your results to get the final number. So what you did here is an example of recursions. You broke the problem into simpler blocks, which is dividing the stack into two and then counting it to get the final result. So within recursions, we have two important terms in a way, I should say, or conditions, which is the base case and the recursive case. Base case is also known as the terminating case because it is the conditional expression that helps terminate a recursive call, whereas recursive case is the condition which helps us continue the recursive call. So now you know what the base case and recursive case means. Can you take a few moments to figure out what the base case and the recursive case in this code snippet would be? Here, if n equals to 0 would become the base case because if that condition is true, then we'll return something over here. It's nothing. We'll just return and exit the function. Whereas if that's not true, then we'll move on to the else part. Then we'll move on to the second if. If that's not true as well, then we move on to the else part. And then we're going to call the function again with n minus 1. And then the whole process repeats itself. Moving on, we'll be learning the difference between recursion and loops. So when it comes to speed, loop is definitely faster, but recursion helps you break down the code into simpler blocks, which can be a very big help when it comes to complex problems. Now, stacks can only be implemented using recursions. They cannot be implemented using loops. Now, condition. What I mean by this is how many conditional expression each holds. So we have two conditional expressions in recursion and one in loop. In recursions, we have the base case and the recursive case, whereas for loops, for example, for loops, we just have one condition in the middle which will help us know whether we have to continue it or terminate it. When it comes to space complexity, uh, recursions better, and when it comes to code readability, recursions is better. Now let's see some advantages and disadvantages of recursions. So the first advantage we have is that the code is very compact. The second one is that it's ideal for complex algorithms. As I had mentioned before, recursions can be used to break it down into simpler and smaller codes, making it easier to solve the problem. Now looking at disadvantages, the first one we have is that it uses more memory compared to loops and it runs slower than a looping construct. Now, could you try and identify the base case and the recursive case in the following program? So here, if n is less than equals to 1 becomes the base case, and in the else part, return quiz this plus quiz n divided by 10. So this part becomes the recursive case, and this part becomes the base case. Now let's look at another example. Could you try and identify the base case and the recursive case? So here, this condition, if count equals to 0, becomes the base case because if it's true, we are printing something and therefore exiting the function. Whereas over here, as you can see, the function is called test and we are in a way calling test minus minus count. Therefore, recursion is taking place. Now, let's look at recursions with the help of a program. So I'll give you guys a few seconds to go through the question and then we look at the program. Okay, so when it comes to solving any recursive program, one tip that's helpful will be try first writing the code using looping constructs because they're one of the basic fundamentals, so they're easy to learn. So try writing the code in a looping construct and then following that logic that happens in the loop and use that logic to apply it and write a recursive code. So now let's look at the program. So here, as you can see, we have import Java because in void accept num we use the scanner class to accept the value of the number that we need to check from the user. And then boolean is pronic, which is our function where we need to use recursions. This becomes our base case and this becomes our recursive case. So over here, if v is greater than the number entered by the user, we're gonna exit the function by returning a false. Otherwise, we're first gonna check if the condition meets that it's chronic number. If this is not met as well, then we're gonna move to the else and then call the function again, therefore recursion takes. And then we're gonna move to void check where we take the value of the return type in the variable c and then compare it in the if construct to see if it's a chronic number or not, and then we have used an object to call the respective functions. Now let's look at the code. So we need to enter a positive number, so let's enter 6. Now 6 is a chronic number because we have 2 multiplied by the preceding number, which is 3, which gives you 6. Let's look at two more numbers. One, we can take it as 5. Now 5, we know nothing multiplied by its preceding number will give you 5. And for the final number, let's take 12. Now 12, we know 3 multiplied by its preceding number 4 will give you the value, which is your answer, the number that the uses. So that's it, folks. This was Recursions for you in a gist. Thanks for tuning in and see you next time.